Okay, so I just wanted to look at general solutions, do it in lots of detail, because if you can understand this one, you can hopefully understand most of them. Basically, the question says find the general solution to the equation 4 sine squared 2x equals 3, where x is an element of real numbers. Now, that's always going to be the domain when we're finding general solutions because, yeah, we're looking for all solutions. So let's just think about what we're trying to do first. We're trying to find where this graph 4 sine squared 2x equals 3. So let's just visually have a look at that. Obviously, the red line here is 4 sine squared 2x, and the blue line is just that 3. And so basically, we're looking for a general solution, a way to summarize all of these solutions. Okay, so that's our task. Let's see if we can give it a go. So first thing we want to do is we want to just try and rearrange things to get x as the subject. So we're going to get 4 sine squared, we're going to divide everything by 4. So we're going to get sine squared 2x equals 3/4. And then we're going to get sine of 2x equals plus or minus the square root of 3 on 2. You got to be careful there. When you take the square root, you've got to take plus or minus. So then what we're going to do is we're going to graph that on our unit circle, which we've got here. And I've just got the acronym CAST, C-A-S-T. Cosine's positive in quadrant 4. Everything's positive. All is positive in quadrant 1. Sine is positive in quadrant 2. And tan is positive in quadrant 3. And then, so what we're going to say is let's just do sine of positive root 3 on 2. So this is where you need to know your exact values. So I've put them here just in case. But sine of root 3 on 2 is, the angle is pi on 3. So sine of pi on 3 is root 3 on 2. So that's going to give us this green line here is at pi on 3. This blue line is at 2 pi on 3. All right, and then we can go in the negative direction as well. So this pink line is at negative pi on 3, and this orange line is at negative 2 pi on 3. Okay, and so then what we want to do is we want to start thinking about our general solutions. Now, the general solution, hopefully you can realize, is if we took this green line and added pi or subtracted pi, we would get to the orange solution as well. And if we just kept repeating that, we'd keep going around in circles and keep hitting our solutions as we do multiples of pi, because you can see that the green line and the orange line are separated by pi radians or 180 degrees. So what we can say, if we just break this next part down, is we're going to say, all right, pi on 3 plus n pi, where n is an element of any number. So that can include going in the positive direction, but also going in the negative direction. All right, and then this part here, let's just try and break this part down, is negative pi on 3 plus n pi. Well, that's just taking this pink line, which is negative pi on 3, and adding multiples of n pi. That's going to get you the blue line as you do that, either in the positive or negative direction. So this here, but remember, the other thing to remember is that we're only solving at the moment for 2x. So hopefully you can see how we sort of came to that. We just picked this green line and this pink line as our angles. And then we're adding multiples of n pi, and that's going to give us all the solutions of our graph. And then so the only thing left to do is to divide by 2. So dividing everything by 2, we get pi on 6 plus n pi on 2 minus pi on 6 plus n pi on 2, where n is an element of integers, so it can be positive and negative. Now, I was asked another question, which might have occurred to you. Why did I pick this green line and the pink line? Why didn't I pick the green line and the blue line? And I'm going to say that you could have done that as well. Yeah, that's also fine. So let me explain what I mean. So there's this confusing line of working out here, but this basically is just the general solutions for sine. The part I'm interested in is that as long as a is between -1 and 1, so as long as the sine inverse of this value is between -1 and 1. Anyway, it's a confusing way to say that, yeah, as long as your exact values that you're talking about are between -1 and 1, you'll notice all of these numbers are between -1 and 1 inclusive, apart from this one. And root 3 actually. But besides these two, these are all between -1 and 1. And we're only interested in sine anyway. So these are all definitely between -1 and +1. So another potential solution, let's explain, would be, all right, I take the green line, pi on 3 plus n pi. So that's the same as before. But the other one we could say is that we take the blue line, which is at 2 pi on 3 plus n pi. So the first one will give us the green line and the orange line, and then taking 2 pi on 3 plus n pi, plus or minus n pi, is going to give us the blue line and the pink line. So that's also a valid solution. And so again, dividing everything by 2 gives us this as a potential general solution as well. So there's 2 answers, and often with general solutions, there's multiple answers. Yeah, because they're just different multiples of each other, or they're just different ways of thinking about how you can get to all the solutions. So let's just have a deeper think about some of these ideas. If we think about the general solutions now, so if we look at this now, the first option we had was this is our general solution, pi on 6 plus I've used k pi on 2. So if we click that on, that's going to, you can see that that's going to give us a solution here, and we're going to get one here as well. So that was that first example I did as one of the general solutions. You'll notice when I change k, that hits all the solutions. That hits all the solutions that we want. But just interestingly, notice that when k is 0, it takes the negative one and the positive one, which makes a bit of sense because in the first example, we took the negative angle. Okay, but you can also do the opposite. No, not the opposite. We can also take the first angle and the second quadrant angle, which would be these 2 solutions. So you notice it'll give us these 2. And then when we change k, it just gives us those solutions. So you can see that it's also a valid answer for the general solutions. Okay, so the next part I'm going to talk about is probably a little bit beyond the methods course, but only a little bit. I think it's actually interesting to think about. So if you're happy with what you've learned there, then that's fine. You can go do something else. But what I wanted to talk about is, yeah, just why those a values need to be between -1 and 1. And so if we look at the graph of sine x here, this is just the graph of sine x. We know that to find the inverse, because you noticed in that general solutions equation had sine inverse of a. Well, that's just a function as well, right? But remember, to find the inverse of a function, the function has to be 1 to 1. So what we're going to do is we're going to take our sine curve, and we're just going to take between negative pi on 2 and pi on 2, because that's going to restrict it to be 1 to 1, because that blue line now would pass the vertical and horizontal line test. So really, we're just looking at this part. And then if we think about the inverse function, well, we know that inverses from previous learning, hopefully, is a reflection in the line y equals x. So it's going to look something like this. Okay, and we can see that the line y equals x goes through there. Okay, so maybe the last thing to say, so this green line is sine inverse of x. Let's see what the range of it is. We can see, hopefully, that the range is going to be from -1 to +1. And if I label these, you can see that the range is from -1 to +1 for sine inverse, and that's because it's the inverse of our sine x graph between negative pi on 2 and pi on 2. So yeah, you can see that the x and the y value endpoints have swapped. Okay, let's just tick off some of these things. I just want that stuff. Okay, and so, we can actually start to understand what's going on a little bit with sine inverse, because we can say, all right, if y is equal to pi on 3, and let me choose a different color for that. We can see that this point here is 0.866. Now, you're probably wondering what that value is, but if you think about it, we've taken the sine inverse, so what was my x values and now my y values. So previously, when my x value was pi on 3, that has an exact value of √3 on 2. So I bet you if I do the square root of 3 on 2, it's equal to 0.866. So it's the inverse of the function. But I suppose the point, it's the inverse of sine. But the point I wanted to make is that you see that the values go from -1 to +1. And when we did the other solution, the second solution, said general solution, we didn't violate the a values not being between -1 and 1. Basically, the a values were between -1 and 1. So that's all good. So yeah, that's also a valid solution. Yeah, good stuff. Keep at it. Not an easy topic.